Lesson 3-7 Practice. Inequivalent equations. Question 1. Noah solved the equation 5x squared equals 45. Here are his steps. 5x squared equals 45. Then he divided both sides by 5. X squared equals 9. Then he took the square root of both sides. Which of the following explanations of Noah's work do you agree with? Well, 3 is an answer, but -3 times -3 also equals 9. Let me show you that in the graphing calculator real fast. 5x squared equals, 45? There's two solutions, 3 and -3. Noah's work is incomplete. It's true that x equals 3 is the solution to the equation, but so is x equals -3 because -3 squared equals 9. Question 2. Match each equation to its solution. Alright, to solve the first equation, square root of x plus 4. And then it's, plus 7 equals 5. To solve this, you have to subtract 7 from both sides, and you get the square root of x plus 4 equals -2. And square roots can never be negative. So there's no solution. The second one is square root of 47 minus x. Square root of 47 minus x. Minus 2 equals 4. To solve this one, you add 2 to both sides. You get the square root of 47 minus x equals 6. And what square root equals 6? That's 36. So 47 minus 11. That's why we can't see the solution. You square both sides, you get 47 minus x equals 36. And the answer is 11. So if I zoom out, you should see the answer is 11. And the last one, 1/2 times the square root of x 20 plus x. One half 20 plus x equals 5. We multiply both sides by 1/2, or by 2. That cancels the 1/2, giving us the square root of 20 plus x equals 10. What square root equals 10? So this has to be 80. We square both sides. We get 20 plus x. And 10 squared is 100. 20 plus 80. This answer is 80, as you can see. Question 3. Which is a solution to the equation the square root of 5 minus x plus 13 equals 4? 5 minus x plus 13 equals 4. To solve this, we have to subtract 13 from both sides. we get the square root of 5 minus x equals, and 4 minus 13 is negative 9. As we know, square roots cannot be negative. No solution. Question 4. Select all the expressions that are equal to 1 divided by square root of 2 to the 5th power. Alright, 1 divided by square root of 2, what was it? Parentheses around it. To the 5th power. You can see they give you an irrational number there. Which ones are equivalent? Well, when the exponent is in the denominator, we can bring it to the numerator and it becomes negative. The square root of 2 to the 5th power is the same as the square root of 2 to the 5th power. These are the same. 2 to the 5th power is 32, and square root of 2 to the 5th power is the same as 2 to the negative 5/2 power. Again, I could check all these by typing them in. That one's 1 over you can see that one's equivalent. The other one is 1 over the square root of 32. 1 over the square root of 32. You can see that one is equivalent. And the last one is 2 to the negative 5/2 power. 2 to the negative 5/2 power. You can see that's also equivalent. Question 5. Which are the solutions to the equation x squared equals 36? X squared equals 36. What number times itself equals 36? Well, that's 6 and negative 6. Alright, you can see that, 6 and negative 6. Question 6. Here's a graph of y equals x squared. Use the graph to estimate to the nearest tenth all the solutions to the equation x squared equals 3. Enter solutions in an ascending order. Alright, so if you use the graph, you could see it's about halfway between 1.5 and 2, and the same here, halfway between negative 1.5 and 2. We're going to say negative 1.7 and positive 1.7. If you square your estimate, what number should they be close to? Well, if you square it, it should be close to 3. Square your estimates. How close did you get to part B? Okay, 1.7 squared, 2.89. When squared, they both equal 2.89. This is blank away from the number in part B. Well, that's 0.11. 0.11. 3 minus 2.89 is 0.11. Last question. The polynomial function q of x equals 3x cubed plus 11x squared minus 14x minus 40 has a known factor of 3x plus 5. Complete the following function so that q of x is rewritten as the product of linear factors. Be sure to write each factor with its term in order from highest to lowest degree. Okay, let's see. I'm going to paste this, Control V, and then I have to change this to cubed, change this to squared, and you get you have a third degree polynomial. You're going to divide it by a fifth degree polynomial, 3x plus 5. That should give you a second degree polynomial, or a parabola. 3x plus 5. Okay, you can see the parabola I was talking about. It has roots at -4 and 2, so the other factors are x plus 4. And you can see it goes through the -4, and x minus 2, x minus 2. And you see I get the same parabola. I'm going to type that in, x minus 2 times x plus 4.